Good evening students and welcome to NPTEL classes. I hope and I wish you are enjoying your life and you are taking due care of your education and you all are aligned with your teachers in your respective institutes. I am here to solve chemistry class 11th NCERT problems 2.40 and 2.42 from unit 2nd of your NCERT chemistry, that is structure of atom. Problem 2.40 is based on Rutherford's alpha scattering experiment. In the problem, it is given that in Rutherford's experiment, Rutherford used thin sheets or thin foils of heavy metals like gold, like platinum, and bombarded thin sheet or foil of heavy metals with alpha particles, which are doubly charged helium ions, helium raised to power +2. Now question says, if we will replace thin sheet or foil of heavy metal with light metal like aluminum, what will be the observations? What will be the contrast? We have to write contrast. We have to write contrast that we will observe in the experiment. Coming to example first. Thin sheet of heavy metal Rutherford used was of gold, or else we can say platinum. Both gold and platinum are heavy metals, and in Rutherford's experiment, alpha scattering experiment, generally thin sheet of heavy metals, these two heavy metals is used, or I can say was used. Now we have to replace heavy metal by light metal, that is aluminum. Question says, if we will replace heavy metal gold or platinum by light metal aluminum, what will happen? What will happen to the observations? What contrast we will find in our observations? I will first make contrast on basis of nuclear size. I will first make contrast on nuclear size. Because gold and platinum are heavy metals, their nuclear size will be large. Size of their nucleus, size of nucleus of gold atom or platinum atom will be large, and size of nucleus of aluminum atom will be small. Second contrast I will make on basis of nucleus of gold or platinum atom will be larger in size and nucleus of aluminum atom will be smaller in size. Second contrast I will make on basis of nuclear charge. as size of gold and as size of nucleus of gold atom or platinum atom is large, it means mass of nucleus of gold or platinum atom is large and mass is due to nucleons, it means nucleus of gold and platinum will have greater number of nucleons as compared to number of nucleons present in nucleus of aluminum atom. Greater number of nucleons means greater number of protons present in nucleus of gold or in aluminum or in platinum, and less number of nucleons here means less number of protons, and we know positive charge of nucleus is due to number of protons in it. So nuclear charge, which nuclear charge? Positive nuclear charge. Nucleus contains positive charge. Positive charge here will be large because of greater number of protons in nucleus of gold and platinum atom. Positive charge here will be small. Now imagine what will happen to number of alpha particle, what will happen to number of positively charged alpha particles when they will pass through thin sheet of heavy metal like gold or platinum, and when they will pass through thin sheet of light metal like aluminum. So next contrast I will make on basis of number of alpha particles, number of positive alpha particles that pass through atom of gold or platinum, or that pass through atom of aluminum. Look, in atom of, realize a picture that in atom of gold or platinum, nucleus, heavy positively charged body nucleus is of large size. Heavy positively charged body at center that we call nucleus is of large size. Then it is natural that heavy rigid positively charged body that we name nucleus at center will allow less number, because it is heavy, it is rigid, it will allow less number of alpha rays or alpha particles to pass through it. So number of alpha particles that pass through will be here small, because they will encounter large size of nucleus which is heavy, rigid, dense, which will not allow maximum of alpha rays to pass through. So number of alpha rays that pass through will be small here, and number of alpha rays that pass through atom of aluminum will be large. Number of alpha particle, positively charged alpha particles that pass through aluminum atom will be large. Why so? Because dense, rigid, heavy, positively charged nucleus at center of aluminum atom is small sized. So maximum of the space around this nucleus is empty. As a result, large number of alpha particles will pass through. This is the main contrast in the results, that through atom of gold, through heavy metal atom like gold or platinum, small number of positively charged alpha particles will pass through, and through light metal atom like aluminum, large number of positively charged alpha particles will pass through. So from here we can conclude that, from here we can take an idea that number of positively charged particles that pass through atom in Rutherford's experiment is inversely related to nuclear size. Here nuclear size is greater. In case of heavy metal atom, nuclear size is greater, so number of alpha rays passing through is small. Here nuclear size is small, so number of alpha rays passing through is large. Next contrast I can make on. Now visualize a situation first. Alpha particles are positively charged. Nucleus is also positive charge. There is repulsion. As a result of this repulsion, alpha rays will get deflected by small angles or by large angles. Now I can make contrast on basis of number of positively charged alpha particles, number of positively charged alpha particles that get deflected, that get deflected. Why deflection? Because these are positive charge. Positively charged nucleus is also positive charge that get deflected. Number of positively charged alpha particles that get deflected. Now see here, positive charge deflection will depend on magnitude of positive charge in the nucleus. Greater the magnitude of positive charge in nucleus, greater will be repulsion felt by alpha particles, greater will be deflection. Because magnitude of positive nuclear charge is large in heavy metal atoms, so deflection will be large here. Heavy metal atom will deflect large number of alpha particles, and light metal atom, because of small positive nuclear charge, will deflect small number of alpha particles. This is one more important contrast. This will be one more important contrast in observations, that number of alpha particles that get deflected in Rutherford's experiment will be large in case of heavy metal atoms like gold and platinum, and number of alpha particles that will get deflected will be small in case of light metal atoms like aluminum. And from here we can take an idea that number of alpha particles that get deflected during this experiment, number of alpha particles that get deflected by atom during this experiment will depend directly on positive charge in nucleus. The atom with greater positive charge in the nucleus will cause greater alpha, will cause greater deflection, will deflect large number of alpha particles, and the atom with less positive charge in the nucleus will cause small deflection or will deflect small number of alpha particles. So from here, two ideas to take are this. First, number of alpha particles that pass through metal atom, is inversely related to nuclear size. Second idea, number of alpha particles that are deflected. Number of alpha particles that are deflected will depend directly on positive will depend directly on will depend directly on nuclear charge. Nuclear charge is positive. Nuclear charge. Heavy metal atom has larger nuclear size. It will pass through it. Less number of alpha particles will pass. Heavy metal atom has larger nuclear charge. So larger number of alpha particles will get deflected. Light metal atom has less nuclear size. Greater number of alpha particles will pass through light metal atom. Light metal atom has less nuclear charge. Has less nuclear charge. Less number of alpha particles will be deflected by its nucleus. So number of if a metal atom allows greater number of alpha particles to pass through, it will allow less number of particles to get deflected. Or if a metal atom will allow less alpha particles to pass through or greater alpha particles to pass through, it will allow less alpha particles to get deflected. And it all depends on nature of metal atom, whether metal atom is heavy or light, and dependence we can correlate dependence on number of alpha particles passed through and number of alpha particles deflected on nuclear size and nuclear charge. Number of alpha particles that pass through has inverse dependence on nuclear size, and number of alpha particles that are deflected has direct dependence on nuclear